Hey folks, I hope you're doing well. I'm going to be talking about this very interesting question about mixtures of cover crops, mixtures that include legumes and non-legumes, and whether or not those can help us to reduce nitrate leaching into our groundwater and therefore help to protect groundwater quality in California. This video is based on a presentation that I was asked to give to the Ag Order Expert Panel of the Irrigated Lands Regulatory Program. I gave this presentation back in December, and I thought, I think it'd make a nice video because there's some interesting information in it. So I hope you find this interesting and helpful. If you don't know anything about the Irrigated Lands Regulatory Program and the Ag Expert Panel, I'll put some links in the video description where you can learn about that. Here's a rough outline of my presentation. First, I'm going to answer this question of whether or not cover crop mixtures of legumes and non-legumes can reduce nitrate leaching. Then I'm going to provide some references to support my answer to that question. Then I'll talk a little bit about the biology and the dynamics of cover crop mixtures of legumes and non-legumes and give you some examples from my long-term research here in Salinas. And then at the very end, I'm going to talk about some of the practical implications of this issue and this question for the groundwater protection here and this new regulation. All right, let's start off with a few basics here. So what types of cover crops can reduce nitrate leaching and protect water quality? Well, non-legume winter cover crops can definitely do that. I gave a presentation last year where I talked about the value of non-legume winter cover crops for reducing nitrate leaching. I'll put a link in the video description if you want to check that out. Now, there's also a lot of interest in fall-terminated non-legume winter cover crops. In fact, I've been involved with a very extensive study with 2 PhD students from Stanford University to try to address this. We're still in the process of analyzing the data, but the data is not as clear on whether or not these types of these fall-terminated cover crops can consistently reduce nitrate leaching. But what I'm going to focus on here today is these mixtures of non-legumes. And I would say the answer to that question of whether or not they can reduce leaching is definitely yes. And let me provide some references to help support this claim that I'm making. One of the best ways to answer a complicated question like this is to combine information from several different studies. And that's what happens in a meta-analysis. And so there are 2 meta-analyses that were done since 2018 that have looked at this issue of nitrate reduction or nitrate leaching reduction by cover crops. The first one in 2018, that one concluded that non-legume mixtures, so non-legume mixtures, they basically reduce nitrate leaching just as well as non-legumes did, but much better than pure legumes on their own. So the mixtures did just as well as non-legumes did. That's a very important finding. Then there was another more recent analysis, and this one concluded that mixtures of legumes and non-legumes were just as effective at reducing leaching as grass cover crops. So grasses are obviously not legumes, so these mixtures of legumes and non-legumes were just as effective as grass cover crops. So that's 2 different meta-analyses to support the conclusion that I came to, that these mixtures of legumes and non-legumes can reduce nitrate leaching. I'll have links to both of those papers in the video description for you to check out. Now, in addition to that, way back in 2003, soon after I started working here, there was also a really nice paper that came out in this Advances in Agronomy book. So they found that these mixtures were often just as effective at reducing the inorganic nitrate pool as non-legumes were. So that's another paper that I would really suggest you checking out. I've got a link to it in the video description. It's one of my favorites because it does a really nice job of talking about the complexity of cover crops. Now here's several other helpful references that I think you might enjoy, and I'll have links to all of these in the video description as well. I'm going to just show you a little bit of actual data from one of these papers. This is the one produced in 2001. What's nice about this study is that they compared fallow to a rye cover crop, so a non-legume, and then a legume mixture, so a rye vetch mixture, as well as just pure vetch. Let me show you some data. So what we've got here is on the y-axis, there's soil nitrate in the top foot, or I'm sorry, not the top foot, the top meter of soil. This is the soil nitrate in the top 50 centimeters, and this is soil nitrate from 50 centimeters to 1 meter deep. So this is the amount of nitrate in the fallow, the no cover crop treatment. And now here's the amount of nitrate in the rye vetch mixture, and then the pure vetch. And you can see that rye had reduced the amount of nitrate in the top meter of soil in a very similar amount to what the rye vetch mixture had done. But vetch on its own was not as good as rye and the rye vetch mixture. So that's an interesting study, and I think one that I think you might enjoy checking out. Let me now give you a little bit of background on the biology and the dynamics of these legume, non-legume mixtures so that you can kind of understand them. I'm going to do that using some data from our long-term experiment here in Salinas, California. This is an experiment that began in 2001. But before I do that, I'm going to take you on a little bit of a trip. We're going to go to the Hawaiian Islands. We're going to go to the big island, the island of Hawaii. And we're going to go over to the Hamakua Coast, which is the wetter side of the island, to a property where I did part of my master's research. So 34 years ago, I planted many different types of legumes at this property, and this is one of them. This is a nitrogen-fixing tree. That's a legume growing in a mixture with grasses in the background. And what you can see here is that the tree, it's dominating the grasses. So the tree has done extremely well. The grasses are still there. But this is an example where the legume has dominated the mixture. Now, here on the same property is bamboo. That's a grass. In this case, the bamboo is actually dominating any legumes that are close by it. So what I'm trying to explain to you here is that these mixtures of legumes and non-legumes, they're complicated. And I often think about those examples from the tropics when I'm down under the cover crop working on cover crop mixtures here in the Central Coast area that are often composed of a cereal like rye or oats and different legumes. In many ways, these understories of these mixed cover crops remind me a lot of tropical rainforest systems that where I grew up and actually where I've worked in the past. So the bottom line is that mixtures of legumes and non-legumes, they're diverse. They come in many different shapes and sizes. They're very interesting as well. Now, one of the common features of all these different types of mixtures is that there are nitrogen scavengers. That's the non-legume component, like rye. It's got a fibrous, very extensive root system, very good at sucking up leftover nitrogen. And then there is the legume component, which is the nitrogen fixing component. Now, we could also call these nitrogen scavengers catch crops because they're catching nitrogen before it leaches down into the groundwater. And then there's the nitrogen fixers, which we could also refer to as green manures. So these two different components of the system are very different, and they can complement each other very well. You've got the fibrous root systems of the non-legume, in this case rye, and then you've got this legume with the nodules that are fixing nitrogen. The legume's root system is not near as extensive as that of the cereal component in this case. In California, there's many different types of cover crop mixtures of legumes and non-legumes. Here's one example. This is a 50% rye, 50% purple vetch. The percentages are based on the seed weight of each component. And then here's another common mixture, 10% oats, and then 90% different types of legume components. Here's just one example of that rye purple vetch mixture. You can see they're growing quite nicely together. And then here's another one. This is actually a rye legume mixture. This is the type that we use in our long-term research here in Salinas. In the Central Coast region of California, these mixtures of legumes and non-legumes are often grown on smaller scale farms or organic farms. Now, I'm going to go through a little bit of some of the advantages and the disadvantages of these mixtures of legumes and non-legumes. Okay, so one of the major advantages, obviously, is biological nitrogen fixation by the legume component. And here's a little bit of an example from some of the data from our long-term experiment here. So this is a paper that was published in 2012, and I'm going to walk you through what we see here. So the two different types of cover crop I'm going to show you is a rye cover crop, so pure rye growing all by itself, and then a mixture, a legume rye mixture. This is cover crop shoot nitrogen uptake, so the amount of nitrogen in the shoots of the biomass, at 3 different periods, from December to January and then February and March. And in both cases here, the cover crops were planted in about the middle of October or early November. So what you'll notice is that with rye in December, the nitrogen uptake is quite high already, but then it plateaus around January or February, doesn't increase anymore from there. So very high nitrogen uptake early on, and then it plateaus by, say, about by January here. Now, if we look inside the mixture, let's just look at the rye component of the mixture here. And you'll notice that the rye component of the mixture takes up a lot of nitrogen early on also, but it continues to increase there. And a similar thing happens with the legume, but notice the legume is not taking up near as much nitrogen as the non-legume component is. Now, we have to acknowledge that some of the nitrogen in the legume is coming from nitrogen that it took up from the soil, but also from biologically fixed nitrogen. And actually, some of the nitrogen that's even in the non-legume, in the rye, is even coming from nitrogen fixation. And I'll explain that in a little bit here. But if you notice, overall, the amount of nitrogen at the end of the season, right up here, this is for the total, this is the legume component plus the rye component of the mixture. The total nitrogen at the end of the season, of the end of this cover cropping season, in the mixture is higher than what occurred in the system with just rye. And that's because we estimate that about 50 kilograms per hectare, or about 50 pounds per acre, of nitrogen was fixed biologically by the legumes. So we've got 50 kilos per hectare or so of nitrogen that we estimate in this case was fixed. And this is data that's averaged over an 8-year period. So this is a very robust data set. Let's now look at the carbon to nitrogen ratio. So this is the ratio of carbon atoms to nitrogen atoms. And this is a really important thing because it affects how easily the nitrogen is released from the cover crop residue once the cover crop is terminated and then allowed to go back or mixed back into the soil. So this is some data from the same study, but a different paper. And what we've got is the carbon to nitrogen ratio of rye, again, growing on its own, and then rye mixed with legumes as well. So here's the mixture data, and here's the rye data. So let's start off with the rye component. The rye component at the beginning of the season, or not the beginning of the season, but early on in the cover crop's growth. This is, again, a cover crop planted in October, middle of October, or early November. So by December here, this bar here, the carbon to nitrogen ratio is probably around 12 or so. And the reason, so that carbon to nitrogen ratio, if you were to terminate that cover crop and mix it in the soil, it's going to release the nitrogen very quickly because there's a lot of nitrogen in there relative to the carbon, and therefore the nitrogen will be released quickly. So that's carbon to nitrogen ratio is about 12 or so. Now notice that that carbon to nitrogen ratio of the rye goes up quite steeply. So by January, the C to N ratio is getting close to 20, but by February or March, it's actually, getting closer up to 30. Now, there's a number here, a carbon to nitrogen ratio of about 20, that's often considered a tipping point between nitrogen released by the cover crop and nitrogen tie-up. With release, we in vegetable systems, you want the nitrogen to be released so that the next vegetable can get it. You don't want that nitrogen to all be tied up in a form that is not accessible to the next vegetable. And so often the sweet spot for cover crop carbon to nitrogen ratios is somewhere around that 20-to-1 number. Now, I just explained what happens with the rye's carbon to nitrogen ratio. Now let's look at rye in the mixture. So in the mixture, the carbon to nitrogen ratio of rye also increases. But notice how the ratio, let's just start with December, the ratio of rye in the mixture is actually lower than rye growing on its own. And again, in January, rye in this mixture is still lower than rye growing on its own. And even at the end of the season, when the carbon to nitrogen ratio of rye growing on its own, or pure rye, has gone quite high, the C to N ratio of rye in the mixture is actually not that high. It's still between about 20 and 25. So what's happening here is that the rye component, this carbon to nitrogen ratio, is being mellowed out or reduced by the presence of the legume. So if you look at the total ratio, this is the legume plus the rye added together, you look at the carbon to nitrogen ratio of that whole mixture at the end of the season, it's very close to that sweet spot of 20-to-1. So what's happening here is that the legume is helping to mellow out or regulate in some ways the increase in the carbon to nitrogen ratio of that mixture. So this mixture will decompose much faster than would occur with pure rye. So you're much more likely to have nitrogen tie-up or immobilization here with pure rye than you would be with a legume cereal mixture. And so that's one of the major advantages of growing a legume cereal mixture, is that it helps to mellow out the C to N ratio of the non-legume component. All right, so you might be wondering, well, how does the legume lower the C to N ratio of rye? Rye can't fix nitrogen, but how is rye getting nitrogen from the legume? Well, there's a very interesting paper that came out in 2016 that talks about the complexity of this. But in a nutshell, and I'll put a link in the video description, you can read about this, but in a nutshell, there are several different ways that nitrogen can be transferred. This is just the below ground component, but there's several ways that nitrogen can be transferred from the legume component to the non-legume. The most important one is the decomposition of roots, dead roots and nodules of the legume. And then those are taken up by the, as they decompose, that nitrogen in those roots and nodules from the legume is taken up and transferred into the non-legume. I'm not going to go into any more detail on this, but if you want to check out that paper, it's pretty interesting. All right, so another advantage of growing these mixtures is that they can often result in higher vegetable yields. And let me show you some data from our long-term study. So here's 2 heads of lettuce. You can see this one head is much larger than the other one. This is just the effect of cover cropping. So in this case, we grew a cover crop, a legume rye cover crop every year, and the heads of lettuce were much larger than where we seldom grew a cover crop. So same amount of nitrogen added in terms of fertilizer, etc., same amount of irrigation. The only difference is that this head of lettuce was grown in a plot that received a legume cereal cover crop every single winter, and this one was grown in a plot that seldom received that cover crop. Let me show you some more data from the same study where we have another cover crop in there. So this is the same experiment, and this is estimated lettuce yields over 8 years. And we've got this legume rye mixture. So we had one system where we grew a legume rye mixture every 4th winter. Then we have another system where we grew the legume rye mixture every single winter. And then we grew lettuce the following spring. And then we have a third system where we grew a rye cover crop every winter. So both of these 2 systems received cover crops every year, every winter. This one only received the cover crop every 4th winter. So you can see both of these where we cover cropped, the estimated lettuce yields with the same amount of nitrogen fertilizer were much higher where we grew cover crops than where we did not grow cover crops. But notice also that in general, the yields were tended to be higher where we grew a legume cereal cover crop than where we grew just pure rye. So in this case, the legume cereal mixture, the yields are higher, and that's quite likely because we had some biological nitrogen fixation from the legume, and that helped to increase our yields. Okay, so now the last advantage I'm going to talk about with these mixtures of legumes and non-legumes is that they're flexible and kind of self-regulating in field situations where there's a lot of variability. Here's some data from that same experiment, but a different graph. This shows you the amount of rye biomass over an 8-year period. And notice how some years this is probably around 7 or so kilogram or metric tons per hectare of rye biomass. And then the next year, the value was quite lower. So you can see it goes up and down quite a bit. And that's because weather situations can change from year to year. Soil nitrogen concentrations can be a little different from one year to the next. And the rye component in the mixture is adjusting based on those different conditions: soil moisture, rainfall, temperature, soil nitrate levels. So the mixture is adjusting from year to year, and that's one of the reasons why sometimes the legume cereal mixtures can be a good fit. If you're not quite sure if you've got a high uniform nitrogen across the entire field or what the weather patterns are like, a mixture can in some cases help to balance that out. Now, or balance out the biomass production or the productivity of that mixture. Here's an example where we actually have variable soil conditions within a field following strawberries. So you can see there's these dark green areas, and then there's these chlorotic areas, yellowish areas. And that's where this is the dark green is where the furrow of the strawberries used to be. This is after the strawberries were harvested and then disked. And these more chlorotic or yellow areas are where the bed top was. So if you planted in this case, this is a non-legume cover crop. This is a cereal, just no legumes in here at all. So you're getting, up and down growth, not uniform growth across that whole field. Now, if you planted a legume cereal mixture in a situation like this, the biomass of that mixture would be much more even across the field, because in the areas where there's less nitrogen, the legume will actually have an advantage and will help growth. And in the areas where there's a lot of leftover nitrogen, the non-legume will do well. So this is a situation where a legume cereal mixture can help with variable soil conditions and help to even things out. All right, let's talk a little bit now about some of the disadvantages of legume cereal mixtures. They're not always a good fit, and I'm not advocating for them always being used. In fact, in many cases in the Salinas Valley, where there's a lot of leftover nitrogen at the end of the season, a mixture of legumes and non-legumes would not be a good fit. But in other cases, it can. Now, one of the biggest disadvantages is the higher cost of the seed. So legume seed per pound or per kilogram tends to cost about twice as much as non-legume seed. And generally, these legume cereal mixtures require higher seeding rates for them to grow well. So the cost of the seed is a big issue. If you plant a legume cereal mixture in a field that's got too much leftover nitrogen, you can waste a lot of money on a legume because the legume won't grow very well in that situation. The cereal will outcompete the legume. Now, another major disadvantage of these legume cereal mixtures can be poor weed suppression. This is what happened in our long-term study. So this is a mixture of rye and different legumes, and we planted it at 125 pounds per acre, but notice these leaves with the serrated edges. That's all burning nettle. So burning nettle is one of the major weeds in this region. This weed was able to grow very well in a legume cereal mixture planted at 125 pounds an acre. And that's not a good situation because over time, those weeds will set seeds and that will increase your weeding costs. Another disadvantage of some of these mixtures can be some legumes can be hosts of soil-borne diseases that can cause some real problems. So you want to be careful with that. Now, because of these disadvantages that I talked about here, at least some of them, several years ago I made a video where I questioned whether or not legume cereal mixtures were a good fit for vegetable production, especially organic vegetable production. You might want to check out this video when you have a chance. It talks about the weed issues as well as some of the seed cost issues, etc. Now, I'm going to kind of conclude by talking a little bit about some of the practical implications for using mixtures of legumes and non-legumes to reduce nitrate leaching. Hopefully I've convinced you that these mixtures of legumes and non-legumes can reduce nitrate leaching. If you go back and look at some of those meta-analyses that I cited, there's good evidence to support that. When the Ag Order regulation passed a few years back and there were incentives for growers, farmers, to grow non-legume winter cover crops to scavenge nitrogen, that really increased the adoption of cover cropping here, especially of the non-legumes. But I think based on the data that I've presented here, we know that these mixtures can also help with reducing nitrate leaching. So to me, it would make sense that if non-legumes are going to be receiving a credit, we would also give credit for the nitrogen scavenging that can happen by the non-legume component of a mixture like a legume rye mixture. But we wouldn't want to penalize farmers for the nitrogen fixation by the legume component. Anyway, that's my thoughts on this. Feel free to reach out to me if you have any questions or comments. Feel free also to put a comment or a question in the YouTube video. Take care and stay well.